We've discussed how to compose two functions, how to take one function g of x and plug it into another f of x. It's pretty straightforward, but it's also important to be able to go the other direction, to see a composite function and be able to determine what pieces make it up. For example, h of x equals 2x minus 3 to the power of 4 is a composition of functions. Perhaps you can see that it's the composition f of g, where f of x, which we think of as the outside function, is x to the 4, that fourth power. And g of x, what we think of as the inside function, is 2x minus 3. It's easy to verify that's correct. H of x, by definition, is 2x minus 3 to the 4. But 2x minus 3, there in parentheses, that's the inside function, g of x. So then this equals g of x to the 4. But a thing to the power of 4 is precisely what f of x does. So in fact, this is f of g of x. Again, g of x we call the inner function, f of x is the outer function. G of x is plugged in to f. You know that this is the correct order because if you tried to go the other order, g of f of x, well, g would say take f of x and multiply it by 2 and then subtract 3. That's what the function g does. So then we would end up having 2x to the 4 minus 3. Clearly, that's not what we want. That's not what h of x is. And so that's how we know that this order, f of g, is correct. Let's go over a couple more examples of writing a composite function as two separate functions that are being composed. Here's our next example. H of x equals 3 over x plus 1 squared, and we want to write it as the composition of two functions. I'll give you a minute to think about this one. When you want to write a function as a composition, you want to think about what's being done to x. In this case, we see 1 is being added to x is being squared, x is in the denominator, and there is a 3 in the numerator. So there's like this multiplication by 3. Now, we could write this as the composition of several functions, or in fact, arbitrarily many functions, but specifically, we want to do this with two functions. So I think about what's immediately done to x. 1 is added to x and it's squared. So that's going to be my inside function. And then the outer part will capture that it's in the denominator and there's a 3 in the numerator. That's going to be my f of x. Here's what that looks like. Like I said, g of x, the inside function, is going to be the first stuff that I see getting done to x plus 1 squared. This is composite as well. We could split this up if we wanted to, but we don't because we want to write this specifically as a composition of two functions. So g of x is fine how it is. F of x, the outer function, like I said, that's going to capture that x is in the denominator, and there's a multiplication by 3 in the numerator, so it's just 3 over x. We can quickly verify that this decomposition works because h of x is 3 over x plus 1 squared, but 3 over a thing, that's what f does. F is 3 over the input. So 3 over x plus 1 squared is f of x plus 1 squared. But x plus 1 squared is g of x. So clearly this is f of g of x. It's not the other way around. It's not g of f of x. If you evaluate g of f of x, you get this. And this is clearly not h. So f of g of x, that's the correct order. I write this out so you can see what it looks like if you pick the wrong inner function. How do I know that x plus 1 squared is the inner function? Well, it's in the denominator. It's getting multiplied by 3. Stuff is being done to x plus 1 squared. And if your intuition fails, you can always just check. This is what it looks like if you get it wrong. One more example. Write the function h of x equals the square root of x squared plus 3 as a composition of two functions. Visually, this is pretty obvious. What's the inside function? Well, it's the thing that's inside the square root. The first stuff that I see getting done to x is that it's squared and 3 is added to it. Again, I could write that as two separate functions if I wanted to, but I'm trying to write this whole thing as two separate functions. So I'm going to let x squared plus 3 be the inside, and that just leaves the square root to be the outside. So f of x, the outside function, will be that square root. G of x is going to be x squared plus 3, that thing in the square root, and we can quickly verify that this works. The square root of x squared plus 3, well, square root, that's what f of x does. So this is f of x squared plus 3, but x squared plus 3 is g of x, so this is f of g of x. If I got the inside and outside functions wrong, and then I ended up having it the other way around, I would get x plus 3, which is clearly not what I'm looking for. So that's how to write a composition of two functions as a decomposition of functions. Let me know in the comments if you have any questions, and be sure to check out my Precalculus course and Precalculus exercises playlist in the description for more. Thanks for watching.
I'm the mathematical menace, the machinations of mankind. Two calculators at the same time, hand signs and abacus, finger count and calculus. I'm the V to the T, my parameter the rapidest. Happens like this, my lecture's the most prominent, dominant. Call me the Morgan, I get the compliments. The union in together like any time that we intersect, cause my opponents know they need